back to geometry, we're at 4.4, using congruent triangles, CPCTC. Now before we start today's lesson, I want to draw two triangles. We're going to call this triangle cat. It's not working. Let's try that again. We're going to try this, or we're going to call this triangle cat. We'll put C, A, and T. And we're also going to draw a triangle dog. And D, O, G. And let's say that on these two shapes, you were told that AC is equal to OD, angle C is equal to angle D, and CT is equal to DG. And then let's say that I asked you, are these two shapes each congruent? Well, you would answer yes, these shapes are congruent by side angle side. Side angle side, side angle side. So what's nice about this shortcut is we don't have to prove that all three sides and all three angles are each going to be the same. They're all congruent. We can just stop right here. Okay, now let's say if I ask you, since these two triangles are each congruent, is segment AT congruent equal to segment OG? And at first you might not be sure because we don't have markings on AT and OG. However, we just proved that these two triangles are each congruent. So of course AT is equal to OG. This is a yes, even though it's not marked, it's true. Now let's say I ask you about angle T is congruent equal to angle G. Are these two angles each congruent? It's not marked. However, yes, these two angles are the same. Okay, the reason why we know is that we just proved that these two triangles are each congruent by side angle side. That means all three sides and all three angles are each congruent. All three sides, all three angles are each congruent. And so that means that AT is congruent equal to OG and angle T is congruent equal to angle G. And instead of saying all three sides and all three angles are each congruent, we can now say CPCTC. So this is what today's lesson is based off of, and we'll use this reason a lot. And the reason why we use this is to prove that the corresponding angles and corresponding sides of these two shapes are also each congruent. And it'll make more sense as we go. Alright, two triangles are congruent if what? Well, if all three sides are congruent and all three angles are congruent. So this means that all corresponding parts must be congruent. CPCTC stands for the following. And we always start with what's given. Then we prove that triangles are congruent. Then we conclude one of the corresponding sides. Now when I say the corresponding side, this is the wrong term. It should be the corresponding parts. And when I say parts, this refers to sides and angles. Okay, so then we conclude one of the corresponding parts, which will include the sides and angles, are congruent. So remember up on the top, when we have this term, the corresponding parts, okay, this refers to sides, and this refers to angles. That's what is meant by corresponding parts. And if we think back and scroll up to this first problem that we just did, we knew that AT and OG were each congruent, even though they weren't marked. These are the corresponding sides. And since these two triangles are each congruent, we know these two sides are also each congruent. And angle T and angle G, these are known, this would be what's known and G, we know that T and G are each congruent. So again, this was our corresponding side. Okay, on this first problem, we're going to try and prove that segment SP is congruent equal to segment QP. Now, before we do that, unapproved, it's always smart to have a plan as far as how we're going to do that. However, before we make our plan, let's always write in our proof what's given. It just helps us get started with it and feel like we have something to go off of. So we're going to do our plan second. For right now, we're just going to we will just write what's marked on here. So we see that angle S is congruent equal to angle Q. That's going to be given. And we see that, let's call it angle 1 and angle 2, that's easier. We see that angle 1 is congruent equal to angle 2, and that's also going to be given. Alright, now we have angle, and if we can prove, so our plan is that we have angle so far, and so I either need a side, well yeah, I do need a side, so if I can show a side, then maybe we can use angle, side, or maybe we use angle, side, angle. So this is the plan to show that these two triangles are each congruent. Now remember that we have a triangle on the left, and then we also have a triangle on the right. So our goal here is to try and prove that these two shapes are each the same, that these two triangles are each congruent. Alright, well hopefully you can tell that this side right here is shared on both sides of each triangle. So we're going to say that PR is congruent equal to PR, and that's by the reflexive property. I'll put REF, reflexive. And so let's put a tick. Let's put a tick on PR, and our tick goes right here. So now you can see that we have angle, side, and angle, side. This is not angle, side, angle. The side is outside of our two angles, or the side is not in between or included of our two angles. So we can now say that these two triangles are each congruent, and the reason why is that we're going to use angle, side. So the way that I name this is I'm going to start with my triangle on the left. Now when you name the first triangle, you can go in any order you want. So I guess I'm going to go and I'm going to call this triangle SPR. And I have to say it's congruent to the triangle on the right. Now notice that when I use SPR, I went one tick, no ticks, two ticks. I have to do the same exact order on this triangle. So again, I went 1, 0, 2. So I have to go 1, 0, 2. That's going to be triangle QPR. Okay, well now we have proven that these two shapes are each congruent. Now that I've proven that these two triangles are each congruent, would it make sense that SP is also congruent equal to QP? And again, these aren't marked. It's not like SP and QP was not given to us. So, you know, from the look at the problem, we weren't sure, but we just proved that these two shapes are each congruent. That means they're the same in every, since we proved that these two triangles are each congruent, that means all three sides, and that also means all three angles are each congruent. Therefore, SP has to be congruent equal to QP. And instead of writing all of this here, I can now use my CPCTC shortcut. But this is really what I'm saying. I'm really saying that these two segments are equal because all three sides and all three angles of these two shapes are each congruent. Alright, second proof. We're going to do a two-column proof as well. And again, before we do our plan, let's get everything down as given. We have angle Q is congruent equal to angle R. Statement 2, let's put angle 1 and angle 2. I can say angle 1 is congruent equal to angle 2. That's good. Alright, and then now that we've done that, let's think of our plan here. Our plan is I'm showing two angles. So again, just like last problem, I'm going to use angle, side, or I'm going to use angle, side, angle. just like last problem, hopefully you can tell that PS is shared with both triangles, so we put a tick here. So PS is congruent equal to PS, and that's by reflexive. And now that I've shown that, we now have to decide if angle, angle, side, or angle, side, angle. Let's start with triangle up on top. We have angle, angle, side is outside. That is definitely going to be angle, angle, side. So by angle, angle, side, these two triangles are each congruent. Next, we have to make our congruent statement. Be careful here, I'll put a little asterisk. We have to be really smart, or just really careful about how we name these two triangles. Remember the first triangle, you can name it any way you want. So let's go with triangle RPS. And if you go triangle RPS, I want 1 tick, 0 tick, no tick. So 1 tick, 0 tick, no tick would be triangle QST. Let me make sure that was right. 1, 0, 2, 1, 0, 2. Good. And that was right. Our angle, angle, side. Alright, we're almost done with the proof, but not quite yet. For the last part, we're being asked is angle RPS equal to angle QST. Well, of course they have to be equal because we just proved that these two triangles are each congruent. So statement 5, we're going to say angle RPS is equal to angle QST. And the reason for that, reason 5 would be CPCTC. Alright, next proof. On a scale of 1 to 10, this is probably about an 8.5. This proof is challenging. In this little box right here, it didn't show up right, but you were actually told that these two lines are parallel, and so these two lines are each parallel. So with these lines being parallel, we don't know that they're each congruent, we just know that they're parallel. Whenever that happens, okay, and you're told this, 99.9% of the time, you're going to use alternate interior angles are congruent. Okay, so just know that at some point in time, we're going to use this to prove that two angles are congruent. And how did I know that? Because we're told that two lines are parallel. So let's extend out these lines. We have WX is parallel to YZ. I extend it out. Alright, next I'm going to highlight my transversal, which goes right down the middle. And also, let's get our proof started. So we're going to do our statement and reason column. And this time, my plan, I know I'm going to use alternate interior angles. I'm not sure yet as far as what I'm going to use as a reason. Remember, we have side, 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 we have side, angle, side, we have angle, side, angle, and angle, angle, side. Just from the looks of it, it looks like it's going to be one of these two again, because we need two sides and three sides here, and we're not told that. We're just told that these two lines are parallel. They're not congruent. Alright, one thing I know is that WY is congruent equal to itself, so let's put that down. WY is equal to WY. This side is shared, that's reflexive property. Alright, next, hopefully you can see that these are alternate interior angles, here and here. Let's call this angle 1 and angle 2. So I'm going to say that angle 1 is congruent equal to angle 2, and that's going to be alternate interior angles are congruent. And hopefully you can tell that these angles as well are alternate interior angles. Let's call it angle 3 and angle 4. So angle 3 is congruent equal to angle 4. And so now, hopefully you can see that these two triangles are each congruent. We have angle, side, angle, angle, side, angle. So we're going to name these two triangles. We're going to say triangle WXY is congruent equal to triangle. And I went from 1 tick, 0 ticks, to 2 ticks. So 1 tick, 0, 2, that's going to be y dw. And the reason why those two triangles are congruent, angle, side angle. And then our last statement is going to be what we're trying to prove. So circle angle x is congruent and equal to angle b. We'll draw our arrow all the way down to here. And the reason why angle x is equal to angle b is by CPCTC. So when do we use CPCTC? Well, we use it after we prove two triangles are congruent. So once we prove that two triangles are each congruent, then all corresponding sides and all corresponding angles must also be each congruent. Alright, the last two proofs. Again, mark what's given. We have wx, we have yz, we have xy, and we have dw. We're going to circle all of this and go into the first box. That's going to be good. Hopefully you see that wy is equal to itself. Wy is equal to wy. That's reflective. Hopefully now let's name this triangle. Let's call this wxy. And we want single, double, triple. So we have to go single, double, triple. That would be y dw. And that's by side, side, side. And so circle this part, our proof part, that goes in last. And that's going to be true by CPCTC. Okay, last proof. On your notes, this is not included. It should have been. So let's get some angles here. We have angle F, angle E, angle G, and then angle E. Alright, and we're told that angle fed and angle jet are right angles. Let's put a box, an angle box here again. We're also told that angle EDG and angle EF are the same. So put one arc and another arc here. So as far as my plan goes on this proof, I already have angle angle. So since I have angle angle, I know it's either going to be angle angle side or I'm going to use angle side angle. It's going to be one of these two. And then after I do that, I'm then going to use CPCTC to prove that EF is congruent equal to EG. So that's our plan. Alright, again, let's get this written down. So one, let's circle all of this. It goes here. And this is going to be given. Alright, one thing we have to do that's kind of repetitive is even though we're told that F, E, D, and G, E are right angles, we haven't said yet in our proof that those angles are each congruent. See, we're told that these two angles are each congruent. We have that congruent sign. We don't have a congruent sign here. So what I have to do is say that in statement 2. I'm going to say that angle fed is congruent equal to angle EDF. Why? Well, because all right angles are congruent. And that makes sense. I mean, all right angles have 90 degrees. So these two angles both measure 90 degrees. They're both congruent. Alright, from there, hopefully you see that ED is congruent equal to ED by reflective. So ed is congruent equal to ed. And that would be reflective. So put a tick here. And then hopefully now you see that we're going to use angle side angle. So we're going to say that these two triangles are each congruent. Let's use triangle fed. It's congruent equal. And if we go fed, FED, I made an error here. Back up on my proof. I said angle fed is congruent equal or congruent and equal to angle EDF. This is an error. This should read angle jet. My fed is congruent equal to angle Z, which is what we showed the 90-degree angles. And triangle fed will be congruent to triangle Z. And that's going to be by angle side angle. And so last but not least, we can now say what we're trying to prove. And we'll draw an arrow down to statement 5. And we say EF is congruent equal to EG. And that's by CPCTC. Thanks for watching.